Hello everyone, today we'll be talking about types of mixtures. First, what's a mixture? A mixture is a physical combination of two or more substances that are not chemically linked. For example, a fruit salad where the fruits are not chemically bonded, chocolate milk, and even smoke in the air is considered a mixture. There are two types of mixtures, homogeneous mixtures and heterogeneous mixtures. In a homogeneous mixture, particles are in a uniform distribution. In heterogeneous mixture, particles are in a non-uniform distribution. Solutions are a type of a homogeneous mixture, while colloids and suspensions are types of heterogeneous mixtures. Let's look at each one more closely, then we'll compare among them. First, solutions. A solution is a homogeneous mixture of two or more substances in a single phase. This means that the atoms, molecules, or ions are thoroughly mixed, resulting in a mixture that has the same composition and properties throughout. The two components of solutions are solute and solvent. The solute is the substance dissolved in a solution, and the solvent is the dissolving medium in a solution. An example of solutions is salt water. In a salt water solution, the salt is the solute, the water is the solvent, resulting in the salt water solution. Although the solid and liquid solution is the most common, there are many other combinations to form solutions. For example, the solutions can be gas and gas, or gas and liquid as shown in the pictures. Another combination that can form solutions is liquid and liquid or solid and solid. Next, let's look at suspensions. A suspension is when particles are so large that they settle out instead of dissolving in a solvent. To consider something to be a suspension, it has to be left untouched. An example of suspension is sand and water. The sand particles are denser than the water. Gravity pulls them to the bottom of the container. The particles in suspension can be separated by passing the mixture through a filter. The other type of heterogeneous mixtures are colloids. A mixture can be considered a colloid when its particles are intermediate in size between those in solutions and suspensions. Let's go back to the example we gave in suspensions. After you mix soil and the water is often still cloudy because colloidal particles remain dispersed in the water. Even when the mixture is poured through a filter, the colloidal particles will pass through and the mixture will remain cloudy. This happens because the particles in a colloid are small enough to be suspended throughout the solvent by the constant movement of the surrounding molecules. Another example of a colloid is milk. As you see in the clip, the particles have an irregular shape and they are in an ununiform distribution. Now, if you have the three types of mixtures in three beakers, how could you know which is a solution, which is a colloid, and which is a suspension? Well, it's easy to know the suspension since its particles settle down, and we can't rely on our eyes to distinguish between a solution and a colloid. That's why the Tyndall effect exists. Many colloids appear homogeneous because the individual particles cannot be seen. The particles are, however, large enough to scatter light. The Tyndall effect occurs when light is scattered by colloidal particles dispersed in a transparent medium. The Tyndall effect is a property that can be used to distinguish between a solution and a colloid. It can also be seen when a headlight beam is visible from the side on a foggy night. In order to experiment the Tyndall effect, let's start by making both the solution and the colloid. To make a solution, I added 1 teaspoon of sugar to the glass of water. In order to make the colloid, I added 1 teaspoon of starch to the glass of water. When the light is pointed at the colloid, the mixture appears glowy and the light doesn't appear in the background. It is scattered because colloidal particles are large enough to bounce off the beam. When the light is pointed towards the solution, you can see the start point and the end point on the glass, but no actual beam appears through. You can also see the light in the background as it passes smoothly without any scattering. Let's see this from another angle. As you can see, the colloid scatters the light and it does not show any light in the background, while in the solution, you can see actually the beam from the background of the solution, but not in the colloid, and that is the Tyndall effect. Finally, let's compare among all three types of mixtures. Solution is the only homogeneous mixture. Both colloids and suspensions are heterogeneous. Solution has the smallest particle size, which is less than 1 nanometer. Suspensions have the largest particle size, which is over 1000 nanometers, while the colloids is between 1 nanometer and 1000 nanometers. Particles of both solutions and colloids do not settle down, unlike the particles of suspension, which do settle down. Another similarity between the solution and colloids is that both of them cannot be separated by filtration due to their small particle size, but the particles of a suspension can be separated by filtration. Finally, solutions cannot scatter light, while on the other hand, colloids can scatter light, as we demonstrated in the Tyndall effect. And as for suspensions, they may scatter light, but it's not always a transparent mixture. Here are some particle models for each type of mixture.